unit weight of soil is weight of soil sample to the volume of that sample. For soils such as hard soil or granular soil, where core cutter method cannot be applied, sand replacement method is used for the determination of unit weight of soil in its natural state. For this test to perform, we will be needing a calibrating sand which passes through 1 mm IS sieve and retained on 600 micron IS sieve. First, we will determine bulk unit weight of this sand, and then using that, we will determine the bulk unit weight of soil sample taken from the field. Firstly, we take a calibrating container and determine its volume by taking its measurements and doing some simple calculations. The volume of the calibrating container is roughly equal to 1000 cc. Cc is centimeter cube. We take a sand pouring cylinder. A sand pouring cylinder is a hollow cylinder which has a cone type structure at the bottom. At the top of that cone there is a small hole so that sand can pass through it. Hole can be opened or closed using a knob provided. Fill the sand pouring cylinder with the sand up to the top and take its weight to note down weight W1. Then we put the sand pouring cylinder over the calibrating container and open the shutter so as to let the sand fall in and fill the container completely. Close the shutter and remove the cylinder. Now take weight of this cylinder with the remaining soil and note down weight W2. We will notice a cone type heap of sand has been made over the calibrating container. To determine its weight, we take a glass plate and put the sand pouring cylinder on it. Again, open its shutter and let the sand fill the conical part of the cylinder. When soil movement stops, close the shutter and remove the cylinder. Then, weigh the soil on the glass plate and note down weight W3. Using these weights, we can calculate how much soil was used to fill the volume of calibrating container. We say this weight as WA, which can be written as W1 minus W2 minus W3. Hence, bulk unit weight of the sand can be determined by its formula and will be equal to this. Now come to the field where soil's unit weight needs to be estimated. Clean and level a small area on the ground. Take a metal tray with a central hole in the middle of it and place it on the cleaned surface. Now, excavate the ground from this hole using a knife up to roughly 15 cm and collect all the excavated soil into the tray. After that, collect all that excavated soil and take its weight. Note this weight as weight of excavated soil. Next, fill the sand pouring cylinder with the sand up to the top again. Weigh the cylinder and note down new W1. Then, place this sand pouring cylinder over the excavated hole concentrically. Open the shutter and allow soil to fall into the hole and fill it completely. When no movement of sand is observed, close the shutter and remove the cylinder. Weigh the cylinder with the remaining sand and note weight new W2. Now, if we remove the weight of cylinder with the remaining soil and weight of conical heap of soil from the weight of cylinder which is full of soil, we can determine the amount of sand that is used to fill the hole, which we say weight of poured soil. Now, here we know bulk unit weight of the sand and weight of the sand which was used to fill the hole. Using the bulk unit weight formula, we can determine the volume of the hole as weight of sand used to fill the hole divided by the unit weight of that sand. Next, now we know the weight of the soil which we excavated from the hole and the volume of that hole. So again, by simply applying bulk unit weight formula, we can calculate the bulk unit weight of the soil we excavated. From this excavated soil, if we take out a small sample and determine its water content, using any of the water content determination method, we can calculate dry unit weight of the soil using this formula, where gamma is bulk density that we have calculated here and W is the water content. Thank you.